My project is titled A Novel Approach to Predicting HIV-1 Protease Cleavage Sites. I came up with this idea because in previous years I have done computer science projects combined with a medical aspect, such as cardiac disease or Parkinson's disease. This year I wanted to try something different, but still containing a medical aspect. Combining looking at the biological makeup of a virus that affects so many people with a computer program that could decrease its effects proved to be very appealing to me. When creating this program to predict HIV-1 cleavage sites, it was interesting to see how all the different algorithms worked, their effectiveness, and their different uses. The engineering goal of this project was to create a program that would be able to predict the cleavage sites of HIV-1 protease. The objective is to do this by analyzing an attribute, the attribute containing several letters, each denoting an amino acid. The program should be able to predict the cleavage site of HIV-1 based on the attribute of amino acids and check its predictions with the cleavage site already given in the data. Another goal is to study the accuracy of the program I've created in predicting the cleavage sites to improve for further use. The program should be able to improve them by finding a better statistical model in R to model substrate specificity in order to develop better HIV-1 protease inhibitors. Various machine learning algorithms have been applied to model the specificity of HIV-1 protease. Understanding HIV-1 protease substrate specificity is significant when developing working HIV-1 protease inhibitors. In addition, it is integral to generating and testing hypotheses of how HIV-1 affects proteins of its human host. This is challenging for three reasons. 1. Datasets with high dimensionality and small sample amount can misguide classification modeling. 2. Symbolic analysis is desirable because it provides insight to the specificity in the form of human understandable rules and helps to design effective HIV inhibitors. And 3. The analysis should factor in the complexity between positions and sequences. To create my program, I used a programming language known as R in RStudio. RStudio is an integrated tool used by mathematicians and statisticians to develop and execute the programs written within it. The algorithms used were random forest, k-nearest neighbors, linear discriminant analysis, generalized linear model, support vector machine radial, naive Bayes, recursive partitioning and regression trees, C5.0, tree bag, and gradient boosting. It took about 2 months to do research on HIV protease and the cleavage sites, then create the program, and then run the program. To briefly explain my procedure, I created 3 different randomized datasets: the trained dataset, the validation dataset, and the test dataset. Creating the program and teaching it how to predict HIV-1 cleavage sites occurs in the trained dataset. In the validation dataset, you validate the algorithm prediction. Finally, in the test dataset, you run final prediction results. In RStudio, I was able to create correlation graphs, visualization graphs, and outcome graphs. It was deemed that there was no correlation between various amino acids as they're all highly different and therefore their correlation was low. Through the visualization graphs, which compared 3 different amino acids and whether there is a cleavage site between those amino acids, the program was able to predict cleavage sites in a chain of 8 amino acids containing a certain triplet of amino acids. Lastly, the outcome graphs depicted that C5.0 and gradient boosting were the most efficient algorithms to predicting cleavage sites. Errors may occur in correlated values, but this was avoided since no correlation was found. Also, outcome may depend linearly on the attribute, so using a polynomial algorithm would affect the accuracy of the algorithm used or vice versa. Checking the accuracy of the different algorithms is one way to avoid the chance of that happening. One way to improve the program is to have the program analyze the patient's HIV sample directly. Also, adding a feature where the program can send urgent results to the doctor would be beneficial. Also, furthering the program by testing more statistical classification and regression algorithms to increase the accuracy of the program is beneficial. This program could be put into practical application at a hospital and medical centers for doctors to use in analyzing a patient's sample to determine an HIV protease cleavage site and developing the correct protease inhibitors for it. Thank you for your time and attention.